In section 8.2, let's look at number 17. Let X be a random variable that represents red blood cell count in millions of cells per cubic millimeter of whole blood. Then X has a distribution that is approximately normal. For the population of healthy female adults, the mean of the X distribution is about 4.8. Suppose that a female patient has taken 6 laboratory blood tests over the past several months and that the RBC count data sent to the patient's doctor are the following. So we have a part 1 and a part 2. Use a calculator with sample mean and sample standard deviation keys to verify that X bar equals 4.4 and S is approximately 2.28. So this is not the population standard deviation. This comes from our data sample. So in part 1, when it's asking you to verify it, you do not want to use these two numbers in your actual calculation or you will have some rounding errors. Use your data. Part 2 says, do the given data indicate that the population mean RBC count for this patient is lower than 4.8? Okay. So let's go ahead and type our data into our calculator. We're going to type it into L1. So we do stat, edit, type it in, each number, and hit enter. Okay. Then part 1 says verify. So let's verify by going stat, calc, one var stats. It's in L1, so I can either say second L1 or just hit enter. And 4.4 is what I got for the mean, and it says S is approximately 0.28. That looks like what we have. Now we're not going to use that data in the actual hypothesis test, or the stats. We're going to use the data. I'll show you in a minute. So when I set up my null and alternative, I do H0 with a colon, H1 with a colon. Make sure you have those colons there, okay? So I know in part 2 it says, do the given data indicate that the population mean RBC count for this patient is lower than 4.8? That's what the alternative is going to be. Lower means less than, or points to the left, 4.8. The null is assuming that our mu is the population mean that we're testing, is equal to 4.8. Since this points to the left, we know this is a left-tailed test. Okay, that's our step 1. Remember, step 2 is the test statistic. At this point, we need to know, are we using a z-test or a t-test? To use a z-test, we need the population standard deviation, or sigma, which is unknown. We don't know this, right? Therefore, we're going to use a t-test. So when we go on our calculators, we go stat, over to tests. Second one there is t-test. We're going to choose that. We have the data in L1. If you ever have the data, always use it. Do not use stats. Okay? Mu naught is what I assume in the null, or 4.8. My data is in L1. Frequency stays 1. This time I'm looking at a left-tailed test, so I have to do less than here. Okay? Points to the left, points to the left. Calculate. So t equals negative 3 we can round this to 2, negative 3.46. Just be careful in WebAssign what it asks you to round to. Okay, I'm going to go ahead and just skip down to step 4 here and write my p-value since I have it there. And usually those, remember they have to be a decimal. If it's not a decimal, look for scientific notation. This one's 0.008. Well, actually we're going to round that up to 9. 0.0090. Usually do 4 decimals. Just be careful what WebAssign asks you for. Okay, so we got step 2. We need to do step 3. We're going to do the critical value. Draw your picture. The picture looks the same for a T and a Z. Go up here. Remember, we look at the alternative. This was a left-tailed test. So instead of being in the right tail, we're going to the left tail. Instead of looking for Z critical, now we're looking for T critical. Okay, in my first video I showed you you had to calculate the degrees of freedom when you're looking for a T, and it's n-1. We had 6 here, so 6 minus 1, or 5. We need that to look it up in our T table. So when we go to our table here, we're going to look for, do we have one tail or two tail? We have one tail. Our alpha is 0.05, so we go one tail over to 0.05, and then our degrees of freedom is 5. So we go down to 5, looks like 2.015. Now because it's left-tailed, even though the table doesn't have negatives in it, so we know if it's left-tailed it has to be negative. What did we say it was? 2.015. Remember, 0 is always at the center. Okay, what we're going to do here is we're going to plot our test statistic. Where does this fall? Does it fall to the right of negative 2.015 or to the left? Think of it as a number line. Negative 3 is on this side of negative 2. Okay, so this is my test statistic. This is my critical value of t. Again, if it falls in this rejection region, we're going to reject H0. If it would have fell over here, we would not reject H0. Our step 4 decision has to be the same, so we're concerned if it's not. Remember, our statement is we're going to reject H0 if the p-value is less than alpha. My p-value is 0.0090. This is a question mark. Is that less than 0.05? Yes or no? Remember, put a 0. Make it the same decimal places. Compare the numbers. Is 500 more than 90? Yes. So this one is less. So the answer is yes. Therefore, we reject H0. Same decision in both these places. Okay? Step 5 is our conclusion. At the 5% level of significance, we do or do not have enough statistical evidence to conclude the alternative. Since we rejected, we do. We do have enough statistical evidence to conclude that, remember that helps you get your wording. I go back to my problem. It said, do the data indicate, oops, sorry, I lost you there, that the population mean RBC count for this patient is lower than 4.8. That's my conclusion. And I had enough evidence to conclude that. The population mean RBC count for this patient is lower than 4.8. Now the trick here is you have to put the units on. 4.8 millions of cells per cubic milliliter. Okay, now do these 5 steps even though WebAssign's only going to ask you parts, because when you do the tests for me, you're going to have to do all 5 steps, okay?